So what we did, we saw all the mathematical operations, okay, addition, multiplication, and then we saw the dot product. So we were supposed to start with the, uh, okay, so the compound assignment operator, okay. So let's define two array. We are going to have array 1 is equal to, before that we need to import numpy, and next array 1 is equal to, I'll be taking two arrays 11, 12, 13. Next we'll be having the second array as 21, 22, and 23. Okay, so this will be the array. So we can do the compound assignment operation also on the numpy array. So we know that compound assignment operation, what it does. So it will be, this is similar like array is equal to array plus 2. Array, like array 1 is equal to array 1 plus 2. It means it will be adding this number 2 to every element of array 1, and the result will be allocated to array 1 back. Okay, so this changes will be done to array 1, and this same array will be allocated to array 1 only. Okay, clear? So this is the compound assignment operation on the array. Next, what operation we are having? Data science model. Okay. So now we'll be looking at the next set of operations which we are going to perform. That is unary operations. Okay. So what is the unary operation? So basically these all operations which you have seen yesterday, those all are the binary operations where you need two operands. Okay. Binary operations needs to be. Now we are going to learn about the unary operations. And in the unary operations, you need only one. Okay. Now in the unary operation, we have an array. What we are going to do, let's say if you want to find the summation of all the elements, you can find array 1 dot sum. Okay, so this will give you the summation of all the elements. This will be giving you the summation of all the elements of the array 1. Clear? Now if you want to find the minimum value and maximum value, similarly using array 1 dot min function. If you remember, these functions we have seen in the list also, and we have this function here in the arrays also. Okay, so min and max function gives you the minimum and maximum values respectively. Clear? Any question? Some disturbance from my end, probably while I'm typing.
Yes, maybe like when it is touching your microphone.
I'm
Like
not
a
touching
step.
the microphone, but I'm typing something. Windy
Yeah.
noise. No. I'm not using the microphone. I'm using systems sound. Okay.
It's fine now, actually.
Okay. Great. Okay. Fine. Let me know. Okay, so these all are the different unary operation, and these all are the aggregate function also to find the summation of all the element, or to find the minimum or maximum value from from an array. Okay. Now these operations apply to the same array. So whatever let's look at this array 1, array 1 dot min, array 1 dot sum, array 1 dot max. These all operation apply to the arrays as we have seen, right? So like in the list, in the sum function you pass the list, correct? In the min function you pass the list. Here you use the dot operator to access or to apply the sum, min, or max function inside the array. Okay. Now this will be working on all the array type, okay, regardless of its shape, whatever shape it is, it will be working on all the array type, this sum, max, and min function. And you can also specify the access parameter. For example, let's say if you have a multi-dimensional array, it is not possible into the single dimensional array, but if you have a multi-dimensional array, let's say array 3 is equal to dot array, and here you have a multi-dimensional array. So we have, let's say, 10, 11, 21, and 23. And we are going to have 22, 24, 45, and 47. And the third element we have here is 98, 76, 45, and 34. Okay, these all are the 4 elements we have. Means we have 3 rows, 4 columns. Let's print array 3. Execute this. We have 3 rows and 4 columns. So we have got the array 3 here, which is a 2D matrix. And now what I want now is I want the summation of all the elements along the rows or along the columns. Okay. Similarly, maximum number along the rows or along the columns, or minimum value along the rows or along the columns. So we have the axis attribute in this sum, min, or max function. So what we can do, we can write here array 3. We can write here array 3 dot sum. Okay, what we want the summation of all the element along the rows or along the columns. And if you'll be writing axis is equal to 0, then this will be giving you the summation of all the elements along the columns. Okay, so if you will be adding these 98 plus 22 plus 10, okay, so it is the result, it is going to be 130. So 130 is printed along the column, and then along the second column the result is 111. Along the third column the result is again 111, and along the fourth column the result is 104. This is what you are getting the result when you put axis is equal to 0. Similarly, when you will put axis is equal to 1, in that case you will be getting the summation of all the elements along the rows. So if you do this, you are getting 3 rows here: 65, 138, and 253. 65 is after adding all the numbers along the first row. You are getting 138 after adding all the numbers along the second row, and you're getting 253 after adding all the numbers along the third row. Clear? Now my voice is clear, or again disturbance is coming?
It's clear now.
Okay, fine. So is it clear, guys? Axis is equal to 0 and axis is equal to 1.
Abhishek,
Yes.
can you please explain again the difference between axis 0 and axis 1?
Axis 0, when you put axis is equal to 0, it will be doing the calculation along the columns. Okay, 0 is, so here you can get this. So let me do here axis in Numpy. So you can see here axis is equal to 0 is this, axis is equal to 1 is this. Okay, so when you are mentioning axis is equal to 0, it will be giving you along the rows, right? So whatever result you'll be getting, maximum or summation or minimum value, whatever you are calculating along the columns. Okay, so first column will be calculated, you'll be getting 0, means whatever is the result. Then second column, all the elements will be added into the second column, all the elements will be added into the third column. So axis is 0 along this, and axis is equal to 1 along this. Clear?
Yes, thank you.
Okay, so if you write axis is equal to 0, it means all the element along the columns will be added. So you'll be getting, so how many columns here? We have 4 columns here, right? So you are getting 4 results here. First result is belonging to the first column, second result belonging to the second column, third result belonging to the third column, and fourth result belonging to the fourth column, and so on. Clear? Any other question?
What if it is axis 2, axis 3? Will they exist or they don't exist?
No, axis 2 exists, but that is into the 3D array, not into the 2D array. Axis 2 is also there. You can see axis 2 is this one, height. Okay, axis 0 is this, axis 1 is this, and axis 2 is the height. Okay, into the 3D array. In 2D array, you don't have. Okay, any question? Okay. Now we have seen this operation. Now let's say if I next operation I'll be doing is the universal operation or universal functions. So what are universal functions? You have universal functions are also called U functions, and these are the functions for arithmetic operation handling. Okay, complex number and statistical functions. So for example, let's now, as of now, whatever we have seen the operators, right? So if you have like, you know, for those operators, plus or subtraction or multiplication or you know, division, for all these operations we are having a universal function or U function we say. Okay, those U functions are also available to us, and we can use those functions to do these operations directly. Okay, for example, let's say now we are going to discuss the universal functions. In the universal functions, you can, like, for adding two numbers, we have np.add, and inside this np.add you can pass the two numbers. So let's say if you'll be passing 12, 13, it will be adding these two numbers and will be giving you the result. Similarly, in np.add you can pass two arrays also, array 1, array 2. When you are passing this, it will be combining these two arrays. So if you remember, array 1 plus array 2 was also giving you the same result, correct? Array 1 plus array 2, element by element addition was happening. Here also you are getting the same result, but now you are using the universal function np.add. Clear? So for almost all the operation, you are having a universal function. Is it clear, guys?
So Abhishek, on that axis 1, axis 0, that is applicable for max and min as well, right?
Max and min, yes, max and min also. I didn't show you. Okay, let me show you the example. This is sum, right? We have this for max, array 3 dot max, and you can write axis is equal to 0. Now this will be giving you the 4 values, okay, and every values will be corresponding to the every column, respective column. So the maximum value into the first column, the maximum value into the second, maximum value into the third, and maximum value into the fourth. So you will be getting it here. So in the first column it is 98, second column 76, third column 45, and fourth column it is 47. Similarly, when you will be writing it axis is equal to 1, it will be giving you the maximum value along the row. Okay, 23, 47, and 98. 23, 47, and 98. Clear? Fine.
So do we get the maximum and minimum of second row, like that, second column, directly?
Maximum and minimum of only second column you want.
Yeah, is there an option to get that?
You have to first access the second column, okay, and then you can do that. For example, how you can access the second column? You will be writing here array 3 of.
Not seeing it, Abhishek, can you scroll up?
Colon, comma, row. You want all the row, and column you want 1. Okay, let's see this. You're getting 11, 24, and 76, right? And then dot max. That is dot. Sorry. Okay, you are getting 76. Clear? This way you can do. Okay, anything else? Any other question?
So Abhishek, for second column, we are writing 1.
For second column, we are writing array 3 colon. Okay, so we are doing this slicing operation and indexing operation. We are combining. Okay, I'll be coming to that indexing and all operation. I'll be coming to that sometime.
Add and sum, both operations are same, na?
No, add and sum are not same. Sum gives you the summation of all the elements. Okay, and add does the element by element operation. Sum is a unary operator. Okay, it needs only one array. Add is a binary operator where you need 2 array to do the operation.
But in this case, you took only one array, right? go down with it.
Where in the sum or in the add?
Add, sorry.
Add, I have taken two array, no? Array 1, array 2.
And the upper line in 112.
This is two numbers I'm adding,
Okay.
not the array.
Two numbers.
Yeah. Okay. Anything else?
So universal functions can be applied to any of the like list or tuple, anything we can apply, but for the list it will just get concatenated, right?
No, you said np dot and it will be applying on the list 10, 20, 30 and 40, 50, 60. Do this. In this case also it is doing the element by element addition.
Okay.
Okay. Fine. If you'll do it on a tuple, so let's take a tuple here. Here also execute this. So you're getting element by element added. Okay.
Okay. Yeah. Thanks, Abhishek.
Okay. Anything else? Any other question?
Abhishek, you are going to explain line number 18 later, right?
Line number 18. Yes, I'll be explaining this one later.
Okay. Okay.
Okay. Fine. So like this add operation, we have the, you can add the array of multi-dimension also. For example, we have array 3 already, correct? Now let's take an array 4 of the same dimension. I'll be having array 4 into 3. So array 4 is equal to np dot arrange. We'll be having 12. Okay. Dot retrieve. 4 rows, 3 rows and 4 columns, 3, 4. Now let's print array 4. So when you are executing it, you are going to get this number. Okay. Now what I will be doing here is I'll be using np.add on array 3 and array 4. Now when you'll be executing this, it is going to give you this result. The first element you had here is 10 plus 0, the result is going to be 0. Then you had next element as 11 plus 1, the result is 12, and so on. So basically, if you'll observe here, element by element addition is done, and this add function works on both arrays and numbers and the other data type also. Okay. Similarly, we have the np.multiply function. This multiply function is equivalent to star function. Okay.
The add function takes only 2 arrays, or we can have a number of arrays?
No, if you'll be taking, let's say, if you are going to take here the third argument, let's see the definition. It may take the multiple argument. Okay. Star as double star kid bar, so it can take multiple argument. So let's say if you have another array 4, array 5. Array 5 is equal to np dot arrange and np dot arrange. We are having here 31 to 42. Okay, and dot reshape. This will be 43. Reshape, and we want 3 rows and 4 columns. Okay, execute this. Now we are going to add array 5. Execute this. So it is taking all these numbers. Array 3, array 4, and array 5. No, it is adding array 3 and array 4 only. What about array 5? One and array 4, array 3 should get. No, it is taking only 2 arguments. If you are passing multiple argument, it is not taking that. It is not adding them. So you will be able to add only 2 arrays. Okay. Fine. Okay, next we have np.multiply and np.log function. So these all are the mathematical functions. Okay, so let's see them one by one. We will not get into the details, but just for knowledge purpose, we'll be covering them. So np.multiply, again, it will be taking two argument and it will be multiplying the two numbers. Multiply and array1 comma array2. It will be multiplying the two arrays element by element. Okay, fine. Clear. So if you see array1 and array2, these all are the array1 and array2, and they have been multiplied element by element. You can take array3 and array4 also, you'll be getting the element by element. In that case, the shape of the resultant array will be similar to the array3 or array4 dimension. Okay, now next we have dot operation. We have already seen. In the case of dot operation, if you remember, we do the matrix multiplication. Okay, next we have np.log function. So np.log will be applying the log to all the elements of the array. So it will be writing array1, it will be applying all the log to all the elements of an array. Okay, fine. Similarly, you can apply np.log to array3. In that case, it will be applying the log to all the elements of the array3. Okay, you are going to get the result accordingly. Next, we have np.sqrt. So np.sqrt is going to apply the square root on all the elements of the array1, and you'll be getting the square root of all the elements. So if you check the array1 was what? Array1 is this one, 13, 14, and 15. Accordingly, we are getting the square root of all the numbers. Okay. Now, similarly, you can apply on the two-dimensional array. In that case, you'll be getting whatever is the dimension of the original array of the same dimension. Will be getting the resultant array also after applying the square root. Next, we have np.square. So np.square gives you the. So we don't have this function in math module, but we have this square function into the Numpy, where it applies the square on every element of the array. So 13 square is 169, 14 is 196, and 15 is 225. Okay, fine. So np.sqrt, np.square, np.log, these all are the three functions. We have the trigonometric function also. In the case of trigonometric function, we have sine, cos, tan, and arc sine, arc cos, and arc tan to find the inverse trigonometric values. Okay. We are not going to get into the details of those trigonometric function, not useful that much. You can check how they are being used. Okay. Yes, we are going to discuss about the bitwise operation. So we know we have seen the bitwise operation into Python. Here also we have the bitwise operation, but we have the universal function for that. Okay. So np.bitwise, and we have np.bitwise or we have, and np.bitwise not we have XOR. Okay, XOR and not. Fine. So let's see this, which all function we have. If you remember bitwise operations. So in the Python, you have bitwise and bitwise or. Here you have, if you want to apply this bitwise functionality, then you have to use np.bitwise underscore and. Okay, and now you can apply the, let's say if you'll be writing 10 comma 20, so it will be applying the bitwise and operation between 10 and 20. You can check it with this one also, bitwise and 10 and 20. The result will be 0. Both are 0. Okay, you can apply this np.bitwise and on the arrays also. For example, np.bitwise underscore and here you can apply the pass the two arrays. Okay, so I'm going to pass array1 versus array2 comma array2. Execute this. So bitwise operations are done on every element, like element wise these operations are done on array1 and array2, this bitwise and accordingly you are getting the result. Similarly, you can do the bitwise or operation, bitwise or operation, and you'll be getting the result accordingly. Okay, bitwise or and then bitwise XOR. Now, if you want to get the bitwise representation of the number, so this is going to be bitwise AND, bitwise OR, bitwise XOR. Execute this, you are getting this result. Okay. Now, if you want to get the bitwise representation, then we have the binary underscore REPR function. For example, there you have bin function, right? Similarly, similar to that, we have binary underscore REPR function, and inside this we can pass any number that will be giving you the binary representation of that number. np.binary underscore REPR you need to write. Okay, fine. So this is going to give you the binary representation of any number, fine, which is equivalent to the bin function, if you remember. Okay, clear, guys?
If we want, decimal representation of binary, do we have a function for that also? np.decimal REPR.
np dot.
For example, our result is 10111. So I want to have decimal representation of it. Is that possible?
No, what you can do, you can assign this to a variable by adding this to 0b. So you may write this way, this result, so 0b plus, okay, that will be giving you the binary equivalent. No, you cannot do that. So that will be in the string format. Decimal representation you have to do this way. You have to get this, so you may write 0b 10111. This will be giving you the decimal equivalent. Okay, now you have to remove the quotation here. That is not applicable. Yeah, we can do this way, no?
Okay.
Okay, we can do this way. We can take any binary value. So basically, we can do this way. 0b, okay, and here we can concatenate it, and this whole thing we can pass to eval, okay, to be giving me the corresponding decimal equivalent. Fine.
Abhishek, will it work on arrays also, binary representation?
Yeah, it will work on arrays also, but let's see when you are having this, what exactly we are getting the result. So one. No, the truth value of an array with more than one element is ambiguous. Use the a.any or it will not work. Rather than what you can do is, no, it will not work. You cannot pass the array. You can pass only the numbers. But OR and XOR operation will work on the array. Okay, bitwise and bitwise or bitwise XOR will work on the array. Okay.
Okay, Abhishek.
Abhishek, wherever we are passing two arrays, like in add, multiply, or bitwise, there the dimension needs to be same of both the arrays.
Yeah, dimension always need to be same. There may be the different dimension, but that is a different case. We'll be learning about it in the broadcasting. Okay.
Yeah.
Anything else? Okay, so now what we have next is, next we are going to see the statistical function now. Okay. Statistical functions in Python. Numpy. Okay, so let's start with this statistical function. What I'm going to do is I'm going to read the data. For that, I need to import the data here. Let me see. Okay, we have the population. Data is not here. Okay. Just give me a second. Let me move the data here. It is into another folder. That is into the data science. Data science, not. September weekday. Okay, done. So now we have the data folder, and from this we are going to read this file using Numpy. Okay, this is the CSV file where we have two columns. One is country name and one is population. This is a comma separated value where in the first column we have around 49 entries of the countries, and into the second column also we have 49 countries of the population. So let's see this. What we are doing here, what we are going to do is we are going to read this data. Out of this population data, we will be reading only the population, okay, not the country name. I just want the population, and then after reading this population data, I'll be converting it into the form of Numpy array. Okay, how we can do that? How we can read the data from a CSV file using Numpy. So to read the data from the CSV file, we have this. First of all, I'll be writing the path from data. We are reading this file, okay. Use columns is equal to 1 and delimiter is equal to comma, skip header is equal to 1. What does it mean? So which column we are reading, okay. So if you'll go inside this, so first column is at 0 index, second column is at 1 index. First column is at 0 index, second column is at 1 index, right? So that's why I have written use column is equal to 1. Delimiter is equal to comma. So here if you'll see the delimiter between the, so if you'll see here Vatican space city, if I'll not mention the delimiter, then by default it will be taking the space as the delimiter, then city will be taken, which I don't want. I want the delimiter to be comma. So wherever delimiter is there, after that whatever column is coming, use read that one, okay. And then we have skip header is equal to 1. We don't want to read the first row. Why? Because this is the heading, right? So we want to skip it. That's why we have written skip underscore header is equal to 1. These all are the attribute which we are using. And gen from txt, this is a function inside the Numpy module using which you can read a CSV file and you can convert it into the Numpy array. So now if you'll be executing this population data, when you'll be printing it here, it is going to give you the population data. All the 49 data are coming here. So it is 1 2 3 4 5 6 7 across 7 rows, where you have total 49 elements. Clear? Fine, everyone.
Abhishek, why we are writing np.gen format txt?
Gen from txt, because we are this gen from txt, we are generating a Numpy array from a txt file. This CSV file is nothing but a text file, right? It is opening it into the text format. So CSV file is a comma separated value. Okay.
So we are we are getting an array from a text.
Yeah, we are getting an array from a CSV file, not from a text. We are getting from a CSV file. Okay.
Okay, CSV file. Yeah.
Yes.
Why we are writing skip underscore header is equal to 1?
Because we are skipping the first row. That is the heading, correct? Country name and then population. That is the heading. We want to skip that.
Okay.
If we want to access multiple rows, we give 1 comma 2 like that.
Multiple rows means
multiple columns.
Multiple columns. Yeah, here use calls, right?
Yeah.
Yes, here you will be specifying the columns.
Skip header, like when I want to leave 2 basically, because 2 rows are my headers. So in that case,
let's see if you will be writing here 1 comma 2. So no, it is not taking. You can pass it inside the. Let's see that. No, it will be like skip header. Generally, it takes only 1. Let me see what all the values we can take. skip underscore header is equal to 0. It's set to 0 by default. Skip rows.
Delimiter is always
You
about.
can use the skip rows. You can use skip rows. Okay. Skip header by default it is optional. The number of lines to skip at the beginning of the file. Okay. So in this skip header you can skip one value, and in the skip rows you can tell that which all values you want to remove, or which all values you want to skip. Okay. Rows basically you want to skip. So if you see that,
skip header is equal to 2, then first 2 lines will be left, right.
sorry, your voice is not audible. Can you please?
If we give skip header is equal to 2, then first 2 rows will be like very.
Okay, let's see that. Skip header is equal to 2. Okay, number you are passing. 792 is taking. Still it is taking 792. Okay. So you can specify one we want to skip. And then let's say if I'll be writing skip rows. Let's see whether it is skip header footer rows is not coming. Okay.
Skip header 2 is working actually. Maybe
Yes,
line 51 is not
line
executed.
51 you didn't execute, right?
First line.
Oh, okay. Sorry, I didn't execute it. Skip rows and then this one. Okay, it is working. So what about this skip rows? We had this skip rows also, no? Skip rows. This is option. Skip rows was removed in. Okay, it is removed now. Use skip header instead. Okay. Fine then. So skip rows basically you can use, but in that case, okay, you are getting the rows total 48 values. So 2 values are skipped. Okay. As of now, let's skip one. So if I'll be writing 3, it will be removing 3 elements, first 3 elements. Okay, that's good. Fine. Anything else? Okay, now let's find the few statistical data here. We want to find the mean, median, and then a standard deviation and variance. So let's see that mean is equal to np dot mean, and we are going to pass the population data. Okay, then we'll be using median. So np dot median of the population data, then SD is equal to np dot standard deviation of population data, and then variance is equal to np dot var, that is the population data. Correct. So these are the different functions to find the mean, median, standard deviation, and variance. Okay, you can print all this information here, and it will be giving you the results. So you can print mean, median, standard deviation SD, and variance, so VAR. Okay, it will be giving you all this information. Name median is not defined. MEDIAN. 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 That's fine now. Okay. Okay. Fine. So these all are the different functions and statistical function we have.
Mode also there.
Sorry.
Mode function is also there.
No, np.mod is not there. So
how we can calculate mode if you want to?
Yeah, mathematics. What is the formula of the mod?
The function we have to do it.
Yes. That is done. Now let's come to the indexing and slicing. Okay. So indexing and slicing on this single dimensional array is very simple. We'll be coming to the 2-dimensional array, where it becomes a bit complex when it becomes like, let's say if you want to access one row or one column, so how you'll be accessing that, we'll be looking at it. And there are different ways of indexing and slicing. We'll be looking at them also. So like this is one of the most important operation, and indexing and slicing. And most of the time we get confused here because there are different ways of doing the indexing and slicing on the arrays. Okay, so indexing and slicing we already know. Indexing is basically what accessing one element at a time. Slicing is what accessing multiple element at a time. Okay, so here in the array also you can access, you can do indexing and you can do slicing. So if you have one dimensional array, right? So let me first write here. We are going to do now indexing and slicing. So in the indexing, we have array one. Let's see array one. And if you want to access, so here we follow the array one of 0. This is the positive indexing. Okay, this is going to give you the first element. And if you'll be writing array one of -1, in this case, it is giving you the last element. Okay. So array also follows the positive and negative indexing both. Okay, now you can do the assignment operation. For example, array 1 of 0 is equal to 100. In that case, it will be printing array 1. So it is going to you are able to see that it is replaced, right? So array supports the basically array, you can say, is the mutable objects. You will be able to make the changes into the array. Okay, now you can do the slicing.
So it's the same as list, no? Like in list and array, they both are like we can assign the value.
Yes, item assignment is possible. But it is different from the list. It is the collection of homogeneous element. Okay, remember that. List as array. List is heterogeneous element. Okay. Now let's print array 1. We are defining the array 1 again. So this one has to be np.array now. np.array. Execute this. This is the array. Okay. Now we want to slice this. So we want to slice this 2 element here. How we can slice array 1 of. So we want to slice from 12 to 13, means we want both the element. So we will be giving the index of 12 as the start index. What is the index of 12? 0, 1, 2. 2 will be the start index colon. 3 is the stop index. So we want to slice till 3, means we want to include 13. So we'll be writing 3 plus 1, which is 4. So it will be slicing this 2 element 12 and 13 from here. Okay, and now you can do this array 1 colon -1, which will reverse the array into the reverse direction. Okay, so basically whatever indexing and slicing operation you have learned on the list, same thing is apply here into the array also. Now the main thing is indexing into the 2-dimensional array. Okay, let's do that. In 2D array, we have array 3 already, which is this one. Now if you want to access here, so you will be giving the rows and columns. Okay, if you want to access any element, you'll be giving the rows and columns. Okay, if you want to access a row, for example, when you want to access any row into the 2D array, so you will be just giving the row number. Okay, so first of all, 0, this row is at 0 index, this is at 1 index, and this is at 2 index. So you can give first the rows. So you'll be writing 0, which will be giving you the first row. If you want to access the last row, you can give array 1 of -1. It will be giving you the last array 3. Array 3 of -1. This will be giving you the last row, 98, 76, 45, and 34. So in the case of 2D array, whatever first value you give in the index, that will be the row or the index of the row. Okay, and if you want to access the columns, then what you will be doing? So in that case, so here let's say -1. Let me write here -1 only. Now let's say if you want to access the a particular element, let's say 11. Okay, so can you tell me what is the index of this row and this column? So the index of this row is 0 and the index of the column is 1, right? So it will be giving you this element 11. correct? So basically, if you want to access one element into the array, 2D array, then you have to give the intersection of row and column index position. Okay, it will be giving you the value. But let's say if you want to access this column, then what I should write? 11, 24, and 76. So what I want the whole rows, right? Row 1, row 2, and row 3. All the rows I want, correct? So here I'll be writing array 1 of column. This is the first, starting from beginning to the end, all rows I want. And column I want only one, right? One, like column is at one index, right? When I'll be executing it, I'll be getting that array 3. This is going to be array 3. Okay, 11, 24, and 76. 11, 24, and 76. Here.
No, Abhishek, please repeat this one.
Okay. See, whenever you want to access the values into the 2D array, it has the row and column, right? So if you want to access one single element, then you have to give the intersection of row and column, correct? For example, what will be the row and column value of 24?
1, comma.
1, 1.
1, comma 1, right?
Yes.
1, comma 1, correct? So if you'll be writing 1, comma 1 here, it will be giving you. Now, see, this you can write in two ways. Either you can use two brackets or you can separate them by comma. Okay, this will also give you the result. 1, comma 1 will give you 24.
24, right.
Okay, so you can write this way, or this same thing you can write this way also. You may write array 3 of 1, and here you may write 1 again in this square bracket. This will be also giving you the same thing. This same thing I have written here. So I have written first this one in this square bracket, then I have deleted this, and then again I have written this. So what I have done, first I have written the rows, and then I have written the column. What column I want? I want this one column whole. And then in terms of rows, what I want 0 row also, 1 row also, and 2 row also, correct? So starting from beginning to end, I want all the rows. So that's why I have done this slicing for the rows, because the first value into the array indexing will be going, multi-dimensional array indexing will be the row value. Okay, so I have sliced the whole row starting from beginning to end, and then I'm accessing the first column into that. Okay, clear? 11, 24, and 76. That's what I have got.
Yes, yes, understood. Thank you.
Abhishek, if you don't mind, repeat the last one. How we got to 11, 24, and 76?
Sorry, last one.
Yeah, I'm a bit confused. How we got 11 and 24 and 76?
Array 3 column. Okay, what it is going to give me?
All the elements of array 3?
All the elements of array 3, correct? Now inside this, I want only the first column, only 11, 24, and 76, right?
Yeah.
So I'll be writing 1 here. This will be giving the first column. Okay.
Okay. Yeah, got it.
Fine. Now it is giving me something else. What it is giving me? 22, 24, 45, 47. Is it what? So array 3 column, then comma 1. Let me see. Yes, 11, 24, 76. Clear? Fine. Here also it should give me 1. It is giving me this one. It's giving me correct. Array 3. Comma 1. Okay. Just now it was working. What happened? It is not accessing this one. Yes.
I think here it is accessing all rows and then giving the first row.
No, but it should. If I'll be giving one, it is working. Just now it was working. No, I have written here it was giving 11, 21, 26. What I made the changes then? So array 3 column.
Maybe you can put a comma between that colon and one, like separately, like you can write inside the indexing.
Maybe colon for the second part, the column part, 1 semicolon 2.
No, 1 semicolon 2. No, this is wrong. Somewhere mistake. What I'm doing here. Array 3 of 0 will be giving me the first row.
Array 3 semicolon is giving the same array again, I think.
Yeah, this is the problem, but it was working just now, no?
It is again taking, if you are giving 1 in the second, then it is giving you the one second row. No, outside, if you are giving.
No, I understood that. What is the problem? But just now I did here and it was working. I don't know. Anyway, probably I have not executed them. But both the indexing are similar. So let me see what is the problem.
Abhishek, why not try for the second column, the third column or a fourth column for any other column?
Right this way. You have to write this way only. This will work. This will work only while accessing the single element, not a whole row or column. So this one is separate. This, okay, so this notation and this notation are both similar. Okay, both are similar, but this will work only when you have to access the single element. This is not going to work when you have to access a single row or single column. Okay, then this notation will not work. You have to use this comma operation only. Okay, in my notes also it is not mentioned. This is not working, I think. So tell me what I should write if I want this element. I want 21, 11, 45 and 76. Sorry, 22, 11, 45 and 76. I want this 4 element. How I should do the indexing or slicing, whatever. How we can access this? Anyone?
We have to get 3 by 3 array and using diagonal gives only diagonal array.
Okay. Array 3, let me see it here. Array 3. So we want 22, then 11, 45 and 76. So can we do this way? Array 3 of 0, 1, 2, 3, 0, 2, 3, and then 1, 11.
One, two, three.
We can pass that 1 minute. I'll tell you. Okay, what is the index? I'll be passing it this way. 1, comma. What is the index? 0, 1, 2, comma 1, comma 0. Let's see. No. Giving the same result or something else. Three zero. One two 1 0 1 comma 2 comma 1 0. This will be inside the list. Okay, and row underscore index equal to yes. So np dot array, and we'll be taking 0 1 2 1. So this will be 0 1 2 and 1. Let's execute this. Row underscore index. Row underscore index is this. Now we will be having array 3. So array 3 of row underscore index comma column underscore index. Execute this. We will get this 11 45 26 22. Yes, this way. Okay. So this is the another way of doing the indexing. Okay, so what I wanted, so first I finalized that which all row values you have to take. So your row values will be 1 2 then 1 and 0 that I have kept here, row value. So I think that I have missed. This should be row value is what 1 0 1 2 and then again 1 and then 0. So row value should be 1 2 1 0 and like different, like I've done like that mistake I've done different ways. So this values will be swapped. 1 2 1 0 will be coming into row index, and in the column index it will be coming 0 1 2 1. Okay, fine. So what are the column values? You have the column values as 0 1 2 1. You have to write it here. In the rows values you have to write 1 2 1 again and then 0. Now when you are passing this as the row and index column, so what it is doing, it is checking the row index, which is the 0. What is the 0? It is the 0 row and the 1 column. So 0 row and 1 column is 21. So 0 row and 1 column, this is it. Row is 0 and column is 1. Yes, so 0 and 1 column is coming 21. It is taking 11. 21. Zero row, one column. This is 0 row, 0 and 1 column. This is fine. Even white is going. Array 3 we have, right? Sorry. Yeah. With this, yes, now it is fine. So 0 row and 1 column. So this is 0 row and 1 column, which is 11. We have got the 11. Then we have 1 row and 2 columns. So this is 1 row and 2 column is 45. We have got 45. Then we have 2 row and 1 column. So 2 row and 1 column is 76. We have 76. And then 1 row and 0 column. So 1 row and 0 column is 22. So we have got 22. Correct. So when you will have row index on column index, so it will be taking one value from row index, one value from the column index. It will be combined together, and that will be the index intersection point of row index. It will be fetching that value from here. Okay, fine. So if you want to access now this 11, 22, 76, and 45, so you just have to swap these values here. We did it by mistake. Column index will be this and row index will be this. Execute this, and finally execute this. You are getting 0, 1, 2, 1. Row indexes. First of all, row index is 1.
Abhishek, 115 you didn't run. 115 you didn't execute.
Okay, now we are getting correct. 22, 76, 45, and 11. Okay, fine. Clear, guys. So this is another way of indexing. The other way of indexing is okay.
Can you explain again, like colon underscore ind and row underscore ind?
Sorry, you want me to explain this?
Yeah, colon underscore ind and row underscore ind.
A row underscore ind is which all rows you want to access, which all values I told you, 22, 76, 45, and 11. So can you tell me that you want in this order, 22, 76, 45, and 11, right? So what will be the rows for this for 22? The first row for 22 is? It is 1.
1, yes.
1, right? So I've written 1 here. Then what is the next row for 76? It is 2. I've written 2. What is the next row for 45? It is 1. Again, I've written 1. And what is the row for next value, which is 11? That is 0, right? So I've written 1, 2, 1, 0. Column index is what? For the first value, the column is what? 22. For the next value, the column is what? Means for the first value 22, what is the column index? It is 0, right? So I've written 0. For the second value 76, what is the column index? It is 1. I've written 1. For the next value, what is the column index? It is 2. I've written 2. And again, for the next value, what is the column index? It is 1. So I've written 1. So this column index and row index are passed. Now if you'll see here, I passed first row index and column index. In Numpy, remember you have to first pass the row and then column. Okay. So accordingly, we have passed, and then element by element it is taking. So this is 1 row and this is 0 index. What is the 1 row and 0 index? This is 0 row, 1 row, and 0 index is this one. So 22 basically we are going to merge. 22 we got. Okay. Fine. Now there is another way of indexing. Let's say we have a array of I'll be just skipping this. Array 6 is equal to np dot a range, and we have 25 or let's say 30 to 60. Basically 31 to 61. Let me see, 31 to 61. Okay. There are total 30 values I'm taking. Dot reshape. I'm doing reshape of 5 rows and 6 column. Okay. Instead of that, let me do one thing. 67. So how many values we have now? 36. So let's do 6 cross 6. Okay, now let's do array 6. Execute this. We have this array 6 where 36 value you have, okay, where the dimension is 6 cross 6. Okay, now what we are going to do is I wanted to access 34 and 40. Can you tell me what I need to do? 34 and 40.
$34 means 0.
3, 3,3 in rows.
No,
Zero from
zero,
zero colon
0
two.
colon 1, 0
Zero
colon
colon 2.
0 colon
2,
2,
comma 3.
3.
3. Okay, correct. Okay, great. Now let's say if I want, I'll be writing array 6, 1 comma, and let's say if I'll be writing 2 colon 4. What will be the result?
38 and 39.
39.
0, 1, 2, 3, 4, right?
39 and 40.
39 and 40, correct? Okay, correct. Now let me know what you'll be getting here. Array 6 of 3 colon comma 3 colon.
Forty-six, 47, 48, 52. That 4 by
Right, or 0, 1, 2, 3, right? So from this row onwards till the end, and then 3 column in slicing. So 52 to 66, this square bracket we will get, correct? 52, 53, 54, 58, 59, 60, and 64, 65, 66. Okay, 0, 1, 2, 3, correct?
Yes.
Fine.
Abhishek, I
Let's
didn't
see
get
this.
the 125 line.
125, 1 comma 2 colon 4. So what is 1? 1 is the row value, right? Which one is the row? 1 row. This is 0, this is 1. This full row is row 1, correct? Now inside this, we are slicing the column from 2 to 4. So this is 0, 1, 2, 3, 4, right? So we have to slice starting from 2 till 4. So we'll be taking 2 and 3 only, right? So it is taking only 39 and 40.
Okay. Yeah, got it.
Okay. Okay. Here, this one is understood, I hope.
And 124.
124, 0 colon 2. So you are taking 0 and 1 because you are starting from 0, you are going till 2, right? You are slicing the row here, you are slicing the column here. So when you are slicing the row, you are slicing the row from 0 to 2. It means you'll be taking 0 and 1. So these two row will be taken into the consideration. And in this two row, you want only third column. So 0, 1, 2, and 3. So 34 and 40 will be taken, 34 and 40.
So first we are taking the row value, then column.
Yes, then column.
Okay, got it.
Okay, so this one, I hope it is understood. Now I'm going to take the next set of values. Let's say if I'll be writing array 6 colon comma 1, what will be the result?
All the
row
data
will
in the
32 to
32,
62.
38,
It's the first
44, 50,
This
56,
one,
62.
right?
Yeah.
Correct, 32 to 62. Great. Now, let me do one thing. I want this value.
Like Abhishek, only colon means like what? Like in 127 line. Colon comma means colon in
Column
the
means we are taking the whole array, okay, here, and then in that I am accessing only first column.
first column.
Okay.
Okay, yeah, got it.
Now in the array 6, I want 33, 35, 45, 47, and 57, 59. 33, 35, 45, 47, 57, 59. These values I want.
Row index and column index, should we create that or without?
33, 35, 45, 47, 57, 59. These values I want. Let me know. Yes, tell me.
Use step, I guess.
Yes, tell me.
Should we create like row index and column index and then extract, or without that also there is a way?
Row index and column. Without that, there is a way using step and slicing.
We will start no row with
Can we write colon 2 here? Why? Because I want to go from first to second and then fourth, right? So this is 0, then second, and then fourth, right? So we'll be writing 0 colon 2. And then I want to start from 33 to 35. So 0, 1, 2. I want to start from 2, right? So 2, step 2, right? Right? I'll be executing it. I'll be getting the same result. 33, 35, 45, 47, 57, 59. Clear? Fine, everyone.
Yes.
In that case, result is printed in another matrix form, basically.
Yes. That will create another matrix.
Okay, but in the above cases, they are coming as a rows only.
No, they are also coming into the matrix. No? So here it is coming. So see, if you are accessing only one column, it will be coming into single dimensional array. When you have multiple values, then it will be coming into the multi-dimensional array. Here also you have only 2 values, it is coming. So it depends that what value you are accessing. If you are accessing one row or one column, then it will be giving into one dimensional array. But if you are accessing multiple values from multiple rows and multiple columns, then it will be giving you into the 2D array.
Okay, so if we access one column, will 1 is colon 1 comma colon work?
Which one? 1 comma colon.
Yeah.
No, you want to say array 6 of 1 comma colon, right?
Yes, Abhishek.
So one row, you want one row and you want all the columns, right? So in that case, this is also going to be, I think, one single row. Okay. So here also, basically you are doing this one only, no? This is equivalent to 0, isn't it?
Abhishek, can you explain 129 again? That 2 colon 2, I didn't understand. 2
Okay.
colon 2.
So colon 2 is what? Colon 2 is, let's say if you'll have array 6 here. Execute this. Array 6 is what? This one. Now in this case, you are writing colon 2. So what is this colon 2? It is starting from 0, like it is the row slicing, right? It is starting from 0, then it is going to 2, then it is going to 4, correct? It is taking every second row in the row slicing. So it is taking this whole row. Okay.
Okay.
Fine. And then it is taking this second row here. And then it is taking this third row here. Okay, every second row it is taking. Clear?
Okay.
It's taking all these 3 rows. Now, next it is starting from 2. So 0, 1, 2, it is starting from here and it is taking every second element from here. So it is taking this column and then this column. Okay. After that, you have nothing, so it will not take. It means 33 columns. So this column and this column it will take. So in this, it will select 33, 45, 57, and 35, 47, and 39. Okay.
But why we are writing like two colons, like a pair of colons? Why we are writing? We can write.
This is the step value. No, we are taking every second value.
Yeah, this is the step value. I understood the first one, and second one 2 colon 2. There I have a doubt.
Here also this is the step value. No, we are slicing the column now. So this is the start value for the column slicing. We want to start from second column. So 0, 1, 2 from second column we are starting. We want to go till the end, but I want to take the step size as 2. So this column will be taken, and after that second column will be taken, right? So second column is this one because of this two.
So we want to go till the end. That's why we have not given any end value. Stop value we have not given for that reason. Right? Like start value is 2 and step value is 2 and stop value we have not given because we want to go till end.
Yeah, stop value we have not given because we want to go till end, correct?
Yeah, got it.
Anything else? Any other question?
Abhishek, I have one question. So if I want to print one column, column 1, how can I do that?
You want to print column 1, right?
Yeah, column 0.
Column 0. Okay.
Yeah.
Column 0 you want to do, then you will be writing array 6 of colon comma 0. Okay.
Coming as a row.
No, 31, 37, 43, 49, 55, 50, 61. It is accessing the first column only, right?
Of course, but representation is like
yes, you want it in the vertical order, right?
Okay.
Then you'll be writing here
You need to reshape.
Dot reshape
1,
1
6.
comma minus 1. Okay.
1 and 6, right?
That is also 1 comma 6 or 1 comma minus 1, whatever, but it is not coming into that. Let me see.
No, it's in the opposite, 6, 1. Right?
6 row and yes, sorry, 6 row and first column, correct. So 6 comma minus 1. Sorry, 6 comma 1. No, it is coming this order. Okay.
Yeah, got it.
Okay, Kishore.
Yeah, got it. Thanks. Yeah.
Okay, so now what is the next? So we have done this. Yes.
Why this is 6?
6 because we have 6 rows here. 1, 2, 3, 4, 5, 6.
Got it.
Okay. Now we have the we have seen this indexing and slicing. We have seen how we can access the random element. Okay, so you can access the values like this also. I've given you an example. So let's say if I want to access 32, 37, 44 and 33. 32, 37, 44 and 33. Using row index, column index, you can do it easily. There is another easier way. You know, packing. Okay, you know the packing. Tuple packing. Correct. Yeah. ARR of 7 equal to, you can say, ARR of 6 of what is this value? 0, like 0 row and first column. So you want 37, right? So 1 comma 0. Here I'll be writing 1 comma 0. Okay. Now next ARR of 6. Next what you want? 2 comma 1. So 2 comma 1. Okay. Then again ARR of 6. Here you want 1 comma 2. So you'll be writing 1 comma 2. And then again you want ARR of 6. Here you want 0 row and first column. So you'll be writing 0 comma 1. Now print ARR 7. ARR of 7. Execute this. You'll be getting all this 37, 44, 39 and 32. Okay. So this is the packing. Okay. This concept also you can apply here.
Abhishek, can you scroll up a little?
Yeah.
So we have an array where we have few elements here. Okay. Now what we want to do, we want to access the this is a multi-dimensional array, right? So as of now, we have this 2D array, and we have seen that, let's say if you want to access this multiple arrays, multiple elements at different position, we have this way of accessing, and another way we have given the row index and column index. This way we have access, right? So we can give this row index and column index again, but in this case now row index and column index will be a 2D array. For example, let's say if I want and guava, jackfruit, and strawberry and blackberry. So guava, jackfruit, strawberry, and blackberry. So 0, 1, 2. Okay. So these values I want basically guava, jackfruit, strawberry, and blackberry. Okay, these 4 values. So this again. So this is like, so tell me what basically what we can do. One way is this way. This is a random value, right? So we can use either row index, column index in one dimensional array, or we can use it this row index and column index into the 2D array. So we'll be writing row index is equal to np dot array, and here we will be writing it into the 2D array. Okay, so we have this, and okay, so 0, 1, and then again 1 and 2, right? Let me write here 0, 1, and this will be 1, 2. Okay, 0, 1, strawberry and blackberry, correct. So 1, 2, and similarly we'll be having row underscore index, column underscore index. So column underscore index is going to have col underscore index is equal to np dot array, and here we are going to have 2 values. What is this? 0, 1, 2. So this will be 2 comma, this will be 1. Okay, and this will be what? 0, 1, 2, 3 comma strawberry and blackberry, right? So 3, 3, correct. Now let's print column underscore index and pass it in the fruit. So let's see whether it is printing those values. Fruit of row underscore index comma column underscore index. Okay, yes, this is fine. Okay, now we can replace the values also. So there we want to just replace the values, let's say mango. So we have replaced the values. If you'll print fruit, these all values are replaced with mango. Okay, so this is what we have. I think that's it. Now last one we have is okay, so let's say we have an array. This is array 6.
Abhishek, those indexes you wrote in 2 blocks, we can write it in a single block, right?
Yeah, you can do it like you had row index and column index here, right? So using 1D array. So basically what I wanted to show here that you can use either 1D array or 2D array as row index or column index, and then accordingly you can pass. Okay, so anything you can use. Okay, fine. Now next we have masked array. We can create the masking array, masked array. Okay, so what we are going to do is we have array 6. Okay, and in the array 6, let's say if you will be writing array 6 you are writing array 6 greater than let's say 45. Okay, so if you will be doing this comparison, then what will be happening? Every element of this array will be compared with 45, and it will be checked that whether it is greater than 45 or not. Whichever values are greater than 45, there it will be replaced with true, and whichever values are less than 45, that will be replaced with false. If you'll be executing it, you are going to get the same array of the same dimension, 6 cross 6. Okay, but here you will be getting these values as true. Why? Because they all are greater than 45, and these values as false. Why? Because all these values are less than 45. Okay, clear? Fine. Now let's say if you want to access these values, so what you can do, there is one way of doing the indexing. The other way of doing this, let's say you have an array where you want to access all the elements which are greater than 45. So you can write array 6 of array 6 greater than 45. Okay, it will be giving you those elements 46 to 66. Okay, you can see it here. Clear? So now what you have done, you have passed this array as an argument to array 6. You can see here to the array 6 for indexing. Okay. Now what happened, wherever the values are true, those values at those index they are accessed, and rest all values are not accessed. You can see it here. Clear, everyone? Is that clear?
Yes.
Okay. Now, next what we have, let's say if you want to find the sum of all the element which are greater than 45. Okay, so we'll be writing array 6 dot sum. This will be giving me the summation of all the element, right? But we want only those elements which are greater than 45. So I'll be writing array 6 greater than 45. Okay. What happened? Array 6 dot sum. Sorry, this will be np dot sum. Okay. Fine. Now, this is going to give me the sum, like, how many elements are there which are greater than 45. If you want to find this sum, then you will be doing this one.
Did it give a count or some?
Array 6. This one. Okay. So to find the sum, of all element which are greater than 45 in array 6. Okay. And if you want to find the total number of element which are greater than 45. Okay, so then you'll be using np dot sum of array 6 greater than 45. Okay, this will be giving you the total number of elements which are greater than 45. Execute this, you are getting 21. So count this, you'll be getting 21. So this is 6 3s are 18 plus 3 21. So total 21. Okay, fine. Clear?
Yes, Abhishek.
Okay, now you can find the sum along the axis also. For example, if you will be writing here, basically I want that along every axis, that how many element we have along every row or along every column which are greater than 45. So I can write axis equal to, if I want along the column, then what I should write, axis is equal to 0 or 1?
0.
0. If I'll be writing this, so it is giving me along the axis which all values are more than 45. Okay, so you will see only 3 values are there. Okay, 1 2 3 which are greater than 45. It is giving 3. Here also 3, here also 3. Here you have 4 4 and 4. So 3 3 3 4 4 4. Okay, now let's say if I want to check it along the column, then you'll be writing 1 in this case. So this will be giving 0, this will be 0, this will be 3, this will be 666, right? So 003 666. Okay, 003 666. Clear? Fine. Okay.
Yes.
Now the last two function, we have np.any and np.all. So np.any, when I'll be writing, in this you'll be writing one condition. For example, if you are writing array 6 greater than 45. Okay, so I'm checking what is there any value which is greater than 45. So tell me, is there any value which is greater than 45? Yes, it is there, right? Correct. So it will be returning true. If there is any value which is greater than 45, then it will be true. If it is any one value also, let's say there is only one value which is 66, right, or which is greater than 65. Okay, so if I'll be writing 65 here, in that case what will happen? In that case what will happen? It is checking any value, means if at least one value is also greater than 65, then it will return true. Okay, and if one value, if like any one value which is not greater than 66, then only it will return false. So in this row, you don't have any value which is greater than 66, right? So this is returning false. Okay, fine. Now next we have np.all. In the np.all, it will be checking np.all whether all the element are satisfying the condition or not. So it will be writing array 6 is greater than, I'll be writing here 30. Okay, I'm writing np.all, all the elements are greater than 30. Then all the elements, it will check whether all the elements are greater than 30 or not. If any one element it will find which is not greater than 30, it will return false. For example, if you're writing this, it is returning true. But if you're writing 35, so there are many elements. If you write, let's say 31 also, so all the elements are greater than 31 except this one. This is equal to 31. So in this case also it will return false. Okay, one element also not satisfied, it will return false. Okay.
Abhishek, I didn't understood row number 158.
158. Okay, so 158 and 156 are similar. This is along the column, this is along the rows. Okay, now what it does, we are checking np.sum. Np.sum of this condition, it checks that this condition is satisfied for how many columns or how many rows.
0 is for rows, na? Then
Zeros. Okay, so axis is equal to 0 when you are writing, it will be, it is for rows, but it will be calculating along the columns, right?
right.
Okay, along the columns. So it will be seeing that condition into the column. So it is checking that array 6 greater than 45. What is the number of element which are greater than 45 into the first column? It is 3, right? So it is returning 3 here. Then in next also 3, next also 3. So 3, 3, 3 you have. Then in next column, next 3 columns, 4, 4, 4. You have 4, 4, 4 here.
Okay, got it.
Yeah. So this is what we have in the indexing and slicing. Let me know if you guys have any question here. Okay, array with this structured data. Now for that, so like that we say structured array or record array, and they are useful whenever you want to perform the computation and at the same time you want to keep closely related data together. For example, let's say if you have some student information, student name, student ID, and student score. Okay, so student name, student ID, and student score are closely related data. And if you want to keep them together, like for one student, student name, student ID, and student score, you want to keep for one student together. Then for second student, you want to keep it again together. For third student, for fourth student, and so on. Okay, so in that case, how you can use this concept of structured array, we are going to look into that. So let's say we have this column, this list basically, which all are the name, student ID, and student scores. Okay, so this is the name, student ID, and scores, correct? Now if you'll be executing it, so now what I want for one student, I want the student ID and student scores to be kept together in an array. How we can do that? So we will be creating one structured data. How? So for that, first of all, I'll be creating one zeros array. Okay, student underscore data is equal to np dot zeros. Okay, now how many student data we have? We have 4 student data, right? So we are going to create a a matrix with 4 element. Okay, where 4 zeros will be there. So if you'll be looking at student underscore data, this is the student underscore data. Okay, as of now, where you have 4 element and all the 4 element are initialized with 0, correct? Now what I want every element to store 3 information, correct? The first information will be name. So instead of this 0, I want this first element to store 3 information: name, student ID, and scores. That will be in the form of tuple. Okay, so how we can structure it? So now there is a d type attribute I'll be taking, and I'll be defining here as d type is equal to the dictionary. Okay, so first of all, we are going to have names here. Names colon. What we are going to have here, we are going to have 3 values. One is name, then student ID, And then we are going to have scores. That will be in the quotation. Let's keep this one quotation, this one also quotation, and this one also quotation. Okay, fine. This one is done. Next, we are going to have the format. So we have to specify the formats also here. Formats, and in the formats, we'll be specifying the data type. What will be the data type for the name? Name, it will be, if you remember, the string data. So that is represented by U10, right, or U8, like that. So U10 I'll be writing. Next, you will be having the number. So for that, you are going to have I4. I4 represents the integer value, and then we will be having float. So float represents F8. Okay, fine. Now, what exactly we have done? So see, you are creating a np.0 with 4 element that we have created. But instead of only zeros, we want to have, for every element, we want to have 3 information: name, student ID, and scores. That we have specified using dtype attribute. In dtype attribute, we are specifying a dictionary where the first element will be names and second element will be format. Okay. Now in the names, we are going to have 3 information: name, student ID, scores, and name, student ID, and scores. And we are specifying the data type into the format, in which format they will be taken. So name will be taken into the string value, student ID will be the integer value, and scores will be the float value. Okay. Now if you will be executing this one, set object is not subscriptable. Where is the error? You type this one column and this one. Okay, so this is going to be, now this is fine. Now let's execute student underscore data. Now if you see, this is student underscore data. As of now, it is filled with 4 data. Okay, so 4 tuple basically. First tuple is having 3 information: one empty string, 0 is the integer, and 0 dot is the float value. Then second also same, third also same, fourth also same. Clear? Now we have to feed this data. Okay, so what we can do, student underscore data of name. Okay, we can write student underscore data of, so this first value are name, right? So I'll be writing here name is equal to, I can write name. Okay, similarly I'll be writing student ID. Okay, right here student ID, here also you write student ID. Next you'll be writing scores. So you'll be writing scores. Here it will be scores, and here also it will be scores. Execute this. Now print student data. Yeah. So now you are able to see that for every student, the information are kept together, correct, in the form of array. Fine. And you have the D type also associated with it, where it is saying name is into the string format, student ID is in the int format, and score is into the float format. Clear? Fine, everyone. Okay. Now out of this, if you want only the name, okay, then we can use here name. Okay, this will be giving only the name of the students. If you want only the scores, then here you can write scores. Okay, it will be giving only the scores. Okay, and let's say if you want to access the first student information, then you can write here 0 index. Okay, it will be giving you the information related to the first student, and the is in ID and his scores. Okay.
Abhishek, what is this U10, I4, and F8?
I4 and F8. I4 is in short form, integer is written as I4 in Python, Numpy, and float is written as F8. This is the code, okay, for integer and float.
And U10 is string.
U10 is this thing. It is representing, it is a string data. Okay.
Okay. Yeah.
Okay.
Abhishek, in case of string, it is printing D type as U10, but in case of scores, it is not printing, I guess.
Sorry.
Why is it so?
In the case of scores, it is not printing. Okay. So generally, when you print this string data, okay, it will in the Numpy it will show you the data type. If you the basic data type or the core data type of the Numpy is integer, float, and complex. Apart from that, if you take any other data, that will be into the U10 format only. And if you have U10 format, it will be giving you the data type, what exactly it is. Okay. Fine.
Okay.
Okay, now let's say if I want the information of the student who are having this course, or name of the student who are having scores greater than 86, how can I do that? So I'll be using student underscore data. What I want the name of the student where score is more than 86. So which all student having a score more than 86? This student and this student, means Rosie and Suzanne, right? So these two names we want. How we can do that? So we'll be writing student underscore data of scores greater than 86, correct? And then we want the names, right? So we'll be writing this. Clear? No field of name. Clear? We are getting Rosie and Suzanne. Clear, everyone? Is this clear?
Abhishek, can you explain the syntax of student data again, once again? That np dot
This one?
the upper one.
This one, np.zeros. Okay. So see, what we want, ignore this one, okay, as of now. Just focus on np.zeros of 4. What we will be getting? We'll be getting a array of 4 element, okay, where every element will be initialized with 0. Clear? This we have seen yesterday. Now, so we will get 4 element where all the element will be 0. But those 4 elements, we don't want to keep only one values. We want to keep multiple values together. Okay. So we want a tuple of values where name, student ID, and scores will be taken. So accordingly, we are specifying the D type attribute, and in that we are taking the names. So names is what? In the names we are going to have 3 values: name, student ID, and scores. Okay. So this tuple is, we are specifying that what every element inside this array is going to have, what all information it is going to have. It is going to have name, student ID, and scores. Okay. And then we are specifying the format that these 3 data will be in which format. So name, we know that it will be in the string, so we are specifying U10. We know student ID is in the integer, we are writing I4, and we know scores is in the float, so we are writing F8. Okay. So we have fixed the data type for this 3 value inside every tuple. Okay. Clear? So we have got the 4 tuple where the first value is empty string, second value is integer, and third value is float, empty float. Okay. Now we have added the data to every element inside this array by saying student underscore data of name. So see, this is name, this is name, this is name, and this is name. So when you are writing student underscore data of name, it is going to give you this empty string, this empty string, this empty string, and this empty string, and that we are replacing with the name values: Andy, Rosie, and Suzanne, and Rick. Okay. So these values are unpacked here. Clear?
Okay, got it. Yes.
Okay.
Just one question. What is names? Like, is it
This name, you can keep anything. You can keep here N, you can keep here ID. Okay. And you can keep here marks. Accordingly, you'll be replacing these values also. So this will be name N, this will be ID. Okay. And this will be marks.
hello?
Yes.
Not that. I was asking about the names and formats that you have written. So what is
Oh,
that?
okay. 1 minute. Let me then change it. Control C. And this will be Control C. Okay. So this names and formats we are taking, these all are the attributes. Okay. When you want to take the structure data, so names will be taking the column names, what all column you are going to have. Okay. Or what all basically you can say what all index names you are going to have. Correct. This is the structure data, right? And structure data will always have a key and a value. Correct. So here you have the value, and these values are mapped with a key. So what key you are going to have, that you will be specifying in names attribute, okay, of the D type. And this formats, in the format will be specifying that in which format those data will be taken.
Okay.
Clear?
So basically, that is like a keyword that
Yes, it is a key. It is a key. Like you have in the dictionary, here also you have the key. Okay.
So names is a key. Yeah? Instead of names, can we put student record, something like that?
No. This names should be there as it is. Okay, this is the key. You have to keep it as it is. Formats.
Right.
This you can change. This you can change.
Are keywords that it understands.
Yes.
Okay.
So
Yeah,
Abhishek, are these the only two attributes that this will have? Or?
No. There are the other attribute also. You can check the definition. As of now, we have taken this. So there are other attributes also, not only these two.
And because it is dictionary, you have D type, is it? Or
No. D type is the attribute of the np.zeros function. Okay, this says that data type. Okay, not because of dictionary. Okay.
It's giving both the name of the attribute and its data type.
So this is the D type. Okay. By default, it is set to float. That's why when I didn't mention D type, it was giving me 0.0.0.0. In the case of np.zeros. Okay. Now, when you'll be checking this D type in detail, so here it is not mentioning. Let me see further. It is not mentioned. Yeah, here you can see how it is custom data type. Okay. So you can do this way also. You are specifying just the values. So xi4, yi4. So what is done? He has taken two values. So in the first value, it is a list. Okay. Is passing the list. Okay. In the list, it is passing the first value will be any number. Okay. That will be the integer. Second value will be also a number, that will be the integer. So you can define it in this way also. Okay. Here. Okay. So check this one.
So Abhishek, data is just like creating a table. I mean, it's just like defining column and the data type.
Yeah, you are defining an array, but as of now my array were having the index, right? 0 1 2 3 0 1 2 3. Now my array has some name. Okay, so here you will see that this is having name, this is having integer, and this is having id, and this is having scores, right? So if you, and this again, name id score, name id score. So if you will be giving a array with the name, it will be giving all the names associated or all the name available into the array. Okay.
Got it. Thank you, Abhishek.
Yes. Anything else, guys?
Can you go slightly up in 174? What is that we are doing? So student data name equal to name. What exactly this does?
This is we are assigning. See, as of now, student underscore data of name is what? Empty strings, right?
Okay.
These all are empty string. Then we want to assign these values to them. Okay, so we have 4 tuples here, and in the 4 tuples we have 4 names, which is the first element, and that we are assigning to these 4 values. Okay, name. That is unpacked.